This panel is on commuter and regional air service. I think that this is one of the places where we're going to see early adoption of electric aviation. We're seeing some of these planes flying now and in certification pathways. So our first speaker today is Seren Weber, and she is the working group lead for NASA's and NARI and the Vertical Flight Society sponsored Transformative Vertical Flight Working Group number 3, which is looking at this commercial intercity long range. She is also a research assistant at the University of Hawaii in the Thermochemical Conversions Alternative Fuels Laboratory, where she studies molecular bioscience, biotechnology, and geosciences to enable genetic modification of organisms for large-scale bioremediation and energy production purposes. And she is an alternative flight and electrification movement enthusiast. So please welcome Seren Weber and her presentation. Go ahead, Seren.
Okay, thank you. Yeah, thank you for the introduction. So as a lead for the working group number 3, commercial long range, I'll be talking a bit about commercial integration into the community, primarily focusing on evtol and hybrid electric propulsion systems. Slide, please. Thank you. A background on the working group, if you haven't heard too much about us, is that we're approximately 60 different individuals of varying backgrounds from industry, academia, and government. We're approaching the electrification movement through commercial applications. We look at various topics and have created a roadmap, matrix, catalog, and are currently working on a white paper. We're also connect industry within the working group to one another for shared benefit, collaboration, and reflections, as well as to NASA Ames Research Center and with Agility Prime SBIR and SDIR programs. Some of the topics that we're looking at are acceptance, technology, infrastructure, and certifications and regulations. Understanding what is already possible and what we project to occur is important to the success of transformative vertical flight in the community. Slide, please. We're looking at comparing and giving an analysis on different technological systems and aircraft to understand the feasibility and appropriate timeline to the revolution in commercial airspace, including looking at fixed-wing amphibious aircraft, light aircraft, powered lift, tilt rotor, tilt wing, ducted fan, fixed motor, multi-rotor, rotorcraft, winged and rotorcraft. Slide, please. Knowing the market and future demands of our communities are important to the success of a rapid implementation of eVTOL. Making these assessments, expanding on and leading with these resolutions will make it easier to implement into the community efficiently. Slide, please. We're looking at identifying the advantages and disadvantages of each type of system and its applications through our catalog informatives, as well as our white paper that are contributed by our members. Slide, please. Once we have established these topics, understanding feasibility and direct implementation challenges, we can begin to look at and help guide certifications and regulations surrounding our newly designed community airspace. Slide, please. We have found infrastructure as a key component in the revolution and integration of community airspace. Without having acceptance, feasibility, and functionality here, then other challenges quickly arise. It is important to understand the direction of electrification in the urban, suburban, and regional environment. It is also extremely important to understand how this infrastructure will tie into existing infrastructure in varying locations. We have found that every topic that we discuss becomes a part of infrastructure very quickly. Slide, please. Our working group also supports an internship program to help decipher some of the topics we were discussing, including a comprehensive review on battery technology, as well as pre-design and sizing technology for dual energy aircraft. We work with universities as well as professors. Slide, please. For the long-range commercial airspace, we're looking at what is possible now and what we expect to see in the future up to 20 years from now with different technologies. Slide, please. The technological aspect of this is crucial to identify and select efficiency and potential for rapid integration. Electric, hybrid, and retrofitted aircraft are essential to this movement. Slide, please. Full technological review and comprehension of existing and prototype aircraft help our industry members move forward in the right direction. Slide, please. Our white paper is the most comprehensive approach to rapid integration of TVF commercial airspace that we're hoping to publish in the next few months with NASA and the Vertical Flight Society. Slide, please. This will be a guide not only for our industry members, NASA and other government agencies, but cities and communities at large around the United States and the world. We have international members and industry incorporated into our approach to ensure an expanding and easily implemented market happens sooner than later. We're asking industry-specific questions such as fuel source, storage capacity, size, and physical traits that fit into vertiport design, required temperatures, pressures, or constraints to be co-located with another source, constraints related to vertiport design, rooftop, et cetera, intercity connectivity ranges, public transportation versus private, if they have a timeline to be selling certified products or timeline to commercialization, manufacturing versus provided flight service. Slide, please. We're looking at approximately 20 sections of discussion across acceptance, technology, infrastructure, and certification and regulations. Slide, please. The culmination of our white paper includes a 3-city case study intended to define parameters of implementation for TVF commercial air across U.S. cities as a platform and template intended for reproduction. Slide, please. We have identified 3 ranges within our working group's parameters. They're inner city, 0 to 50 miles, intercity, 150 to 500 miles, and suburban environment, 50 to 500 miles. We're looking at PAVs, commercial applications, and cargo as well. Slide, please. This shows the 500-mile range population and counties included in our 3-city case study. And if you'd like to know more, please contact me. Thank you for your time, and I hope you enjoyed my presentation. I'll go ahead and give it back to you, Yolanka, now. Thank you.
Thank you, Seren. That was wonderful. I think we will now roll on to Brian German. Brian is the co-director of Georgia Tech Center for Urban and Regional Air Mobility and is the National Institute of Aerospace Langley Associate Professor in the Georgia Tech School of Aerospace Engineering. He specializes in configuration design of electric aircraft, battery electric propulsion modeling, and operations research problems for innovative, scheduled, and on-demand air services. Brian is a founding member and former chair of the AIAA Transformational Flight Program Committee, which was chartered to explore the opportunities of emerging aircraft electric propulsion technologies. And he's a member of the AIAA Aircraft Electric Propulsion and Power Working Group and an associate fellow of AIAA. Brian, it's all yours.
Thank you, Yolanka. So Yolanka asked me to talk a little bit about work that we've done at Georgia Tech over the last few years related to commuter aviation. So with that, next slide, please, Yolanka. In around the 2016 timeframe, we started looking at a topic that NASA was interested in at the time that was called thin haul aviation. And the basic idea of thin haul is commingled with current commuter airlines and what we think of as a 9-passenger category aircraft that flies people over relatively short distances. And the term thin haul sort of emerges out of the notion of looking at all the different routes that you could fly and sorting those routes by demand for those routes. And so if you were to do that and take all of commercial aviation and sort by demand, you'd notice that the first few routes are certainly the dominant routes we recognize to commercial airports in the US. So this might be LA to Boston or things like that. And then as you get farther down in this demand ladder, you eventually get into short haul, regional aircraft in the 30 to 50 seat category, and finally down into the 9-passenger category aircraft that we'd recognize as commuter airlines. And if you think about it this way, all the city pairs that could be addressed by these really short distance flights, these commuter flights, is really enormous across the nation. There's potentially thousands of these routes that we could operate but not many of them are really being served, right? So the question is why? And the cumulative demand really could be significant if we think about the number of people who might want to fly relatively short routes. And so really the question is why, and the question is how do we enable that to happen? Next slide, please. So the airlines that serve this type of market are typically referred to as commuter airlines. And you see a few of them over here on the right, Cape Air operating primarily in the Northeast, Surf Air operating in the California area, and Mokulele operating in Hawaii. Most of these airlines fly 9-seat airplanes, as I mentioned. So the Cessna 402 for Cape Air, that's now being replaced by the Tecnam P2012. Surf Air operating the Pilatus PC-12, and Mokulele operating the Cessna Caravan. Now, to close the business case for some of these operators, and in some particular applications, there's the so-called Essential Air Services Program, which is a congressionally subsidized program to, in the post-deregulated era, offer routes that are typically rather thin, but they're absolutely critical for those communities. So many of these airlines fly essential air service routes, but they also fly routes that are not subsidized, that are economically viable. And those routes tend to be flights for which the comparative road route would be very long or very, very circuitous. And so flight is really the winning value proposition. Next slide, please. And so the question might be, why don't we see more of these aircraft and more of these flights? And fundamentally, in the post-deregulation era of aviation, the answer must be economics. And basically, an operator, as a commercial entity, has an ability to choose their own routes, and they do so based on profitability. So profitability is basically the revenue side less the cost side. And revenue is a rather complicated challenge for these operators because, of course, revenue depends on pricing, and in order to stimulate demand, and pricing depends on how low you can lower the operating costs. So it's a quite challenging dynamic that creates a pricing elasticity, or a demand elasticity to pricing, which is driven by operating costs. And that's a very classical notion in aviation economics, but the story is not quite so simple for these short range flights. For one, the aircraft themselves tend to be piston engine powered historically, which does not offer the best cabin noise environment. They also tend to be relatively low wing loading aircraft, which does not offer the best ride quality. And additionally, you're always competing with not other forms of aviation, but car trips. So you're really thinking about how can we get door-to-door time to be as short as possible in order to make a business case. So it's a really complicated situation. Next slide, please. And the operating cost picture, which is a key driver of demand, is driven by several big chunks of cost. Two of them are very strongly related to the aircraft design: the fuel costs and the maintenance costs of the vehicle. And you'll see in this depiction that they are the most significant portion of the cost picture. So in this, we see opportunity because this is an electric aircraft symposium. And one might ask the question, what could we do to address the energy cost issue and the maintenance cost issue with electrification? And of course, on a per unit energy basis, we can source energy from the electrical grid, arguably quite a bit less expensively than we can source aviation gasoline. And on the maintenance side, if we go to electric propulsion systems with fewer moving parts, we can potentially dramatically reduce the maintenance costs as well. Next slide, please. And the fuel cost and fuel efficiency piece of the puzzle is quite important. And we know that electrification can impact this. But if we first look at, sort of what the fuel efficiency is and the corresponding fuel cost implications are for a traditional piston engine powered fixed wing aircraft, we can see that the picture is actually pretty surprising. It's not a very good picture. Namely, we end up with aircraft like the Cessna 402 and the Pilatus PC-12 having thermal efficiencies on the order of 23 to 28% range for these two aircraft that you see in these examples, sort of buried in the numbers there on the right-hand side of the slide. The corresponding result is a relatively low specific range of the airplane, measured in nautical miles per kilowatt hour in this case, rather interesting unit. Next slide. And so again, how could we improve that situation? And NASA looked into this in the 2016 timeframe through a series of workshops and meetings that were organized by the National Institute of Aerospace. And there were a series of working groups that looked specifically at this, this problem and asked what could we do in terms of vehicle technology to reduce the energy costs, to reduce the maintenance costs, but also to look at the airspace integration issues and look at other aspects that would facilitate an improvement in demand for these types of air services. And here's a list of the conclusions from that series of workshops, indicating the value of electric propulsion, simplified vehicle operations, airspace integration, manufacturing and integrated structures for purposes, by the way, of both reducing aircraft empty weight and improving the fuel costs from the fuel energy cost and energy requirements from that perspective, but also from the ability to manufacture these aircraft quickly enough and at low enough costs. And finally, community impact, which is something that we're very cognizant of in urban air mobility, and also looking at those considerations from the standpoint of regional and commuter flights. Next slide, please. NASA, of course, was looking at these sorts of technologies through their X-57 program, and that's still ongoing. And at the time, Joby Aviation was also doing studies for NASA looking at electric fixed-wing aircraft with distributed electric propulsion that could achieve considerable energy cost reductions. And of course, Joby's now moved on to look at a lot of exciting new VTOL technologies, as Greg was just talking about in this session. Next slide, please. And the key advantage of distributed electric propulsion for purposes of commuter aviation could really be looked at as, again, getting the energy cost out of the system. And from a pure efficiency standpoint, electric is a clear win. Of the amount of energy that we store on the aircraft, we can arguably extract on the order of 90 to 95% of that energy to the shaft of the propeller. Quite a significant thermal efficiency from the transfer of energy storage to propeller power. And this is in contrast to on the order of 23 to 28%, as we showed earlier, for a typical piston engine aircraft. So in that case, the situation is really quite wonderful. However, the challenge, of course, as we all know with all electric aircraft, is storing the energy. How much energy can we actually store aboard the aircraft? And that's highly limited by our battery-specific energy, which is the big technical challenge that everyone's working across the entire realm of electric flight. But the potential comes in now once we've embraced electrification to distribute propulsion, to achieve favorable aeropropulsive interactions. And in the cases that NASA looked at in the X-57 design, for example, the ability to do things like cruise size your wing, to allow the size to be reduced, to reduce wetted area, increase wing loading, and potentially dramatically improve the aerodynamic efficiency. So with those types of modifications, at the time, people were talking about 0.4 nautical miles per kilowatt hour, which would be nearly double the specific range of the piston-powered aircraft in the legacy fleet. Next slide, please. And just to highlight a very few things that we've done at Georgia Tech in this area. I've talked a lot about the backdrop. We've carried out several different studies with NASA support to look at commuter aviation in the era of electric flight. And I'm highlighting a few of those here with some representative papers. Most of these are actually operationally oriented papers and less focused on aircraft design or aircraft technology. Some very interesting work that we did, and personally I think very interesting work in battery swapping and battery recharge strategies. And this was led really by Cedric Justin at Georgia Tech and Alexei Payan, who worked on this for quite some time in a NASA grant that we had a few years ago. That research has recently been published in Transportation Research Part C. Work on optimal flight speeds when you consider the need for recharging between missions for scheduled aircraft operations. We also, and again, Cedric Justin, I just mentioned, spent quite a bit of effort looking at a short takeoff and landing with electric aircraft and a variety of infrastructure placement problems and optimization problems, considering winds and other real world effects. And there's several papers in that series. I'm showing just one of them here. And lastly, we've looked at eCTOL operations in more of a even shorter range context, even intra-city from existing regional airports, and shown certain cases where that can really offer quite a bit of a value proposition with these fixed-wing aircraft, even in the case of just a retrofitted type of configuration. So I think that's all from my side, Yolanka.
Brian, thank you so much. That Georgia Tech has, and your team there have done such great research over the years, and I really appreciate you coming on and sharing that with us. It provides a lot of background and context for this area of electric aviation. So thank you.
Thanks.
Our last speaker for this panel is Ken Swartz. Ken was elected to the Board of Directors of Vertical Flight Society in 2018 to represent the Americas, Canada, Central America, South America, and he's Director of Marketing Communications for the Electric Aircraft Symposium. He's a Senior Aerospace Marketing Communications Strategist with Aero Media Communications, working with clients across the helicopter, VTOL, and commercial aviation sector. His professional career includes more than 30 years in the commercial aviation marketing and market analysis with helicopter charter operations, regional airlines, and regional aircraft manufacturers such as Bombardier Commercial Aircraft and Dash 8, where he worked on CRJ Regional Jet and Dash 8 turboprop sales campaigns. So please welcome Ken to talk about the regional opportunities for electric aircraft.
Hi, Yolanka. Can you hear me clearly?
Yes, we can hear you.
Okay, so I got kicked off the GoTo webinar after, I guess, being on it multiple times this week. So I'm flying a little bit blind. So could we have the slide that says, the second slide that says the airline, please? And just confirm it's up.
Yes, it is up.
Okay, so in the pioneering years of aviation, an airline was an idea, not a service. In time, airline route maps were published that were manifestations of business plans. The airline product is an origin, a destination, a schedule, a fare, and various amenities. In the short-haul market, frequency builds ridership. Next. When we look at short-haul aviation services today, it can be segmented into a number of different aircraft categories or service categories that are all ripe for electrification. In Canada, we had a great history of bush flying, which meant flying year-round on wheels, skis, and floats. And so the aircraft designers made rugged aircraft, and one of the outcomes of trying to fly into a small lake was creating an aircraft with great stall performance. But short-haul aviation is challenging to both operators and aircraft manufacturers. For short-haul airlines, high-cycle operations come with high operating costs. And as airlines grow, they traditionally abandon the thin-haul routes, especially if they're affiliated with a major carrier, or the time value of their service is undermined by things like airport security, inadequate ground infrastructure, etc., unless alternative modes are not competitive, largely because of geography. So this creates a fertile market for electric aircraft. Next. if we look at short-haul air service today, one of the target markets for electric VTOL aircraft is a market that was once filled and is filled in certain locations around the world by helicopter airlines. In the 1950s and 60s, thousands of people a month were commuting by helicopter. In Europe, Los Angeles, New York, Chicago, and San Francisco. An extensive heliport infrastructure was in place, and the flights were subsidized either by mail contracts or directly by governments. When government subsidies ended in the mid-60s, there was a high failure rate amongst those helicopter airlines. Today, there are 28 helicopter airlines in the world, and they, for the most part, only fly a couple routes, perhaps with the exception of Greenland. These services, if you look at the maps, and next, this is a historic shot of New York Airways. I'm just going to jump ahead. San Francisco Airways, next. Next is LA Airways. Because I can't see the screen, I'll just speak to this one for a sec. LA Airways offered an extensive helicopter network in the LA basin from 1954 to 1970, after initially starting with airmail flights. The infrastructure was easy to put in place, but most of the infrastructure that served this network has disappeared as real estate prices have increased and properties have been developed. Next, to achieve low seat mile costs, LA Airways operated large capacity helicopters, a Sikorsky F-61L with 28 seats, a flight attendant, and underfloor baggage space. But when subsidies from the government and from airlines disappeared and costs increased, the airline folded. Next, if we look at air services today, we have a number of helicopter airlines active in Europe, in Norway, in Spain and connecting to Spanish enclaves on the north coast of Morocco, in the south of France, to Nice and Monaco. Next, we have helicopter airlines serving Penzance in the Scilly Islands, in the UK, in the Faroe Islands, and in Italy. Next, and in Asia, we have helicopter airlines serving Hong Kong and Macau and Shenzhen, and also offshore in Japan. Next, and in Greenland, we have an extensive network of helicopter airlines and stall ports serving the west coast of Greenland, the populated areas. The common element in all those route maps of current services today is geographic obstacles, largely water. Next, one of the most successful helicopter airlines is Helijet International in Vancouver, British Columbia, my hometown. I was there when they launched service in November 1986 and took off on their first flight, and everyone predicted the company would fail. But they had the right O&D markets, the right infrastructure, the right passenger base, the right fare structure, the right aircraft, and most importantly, the right management. Next. Today, Helijet is looking at opportunities to integrate eVTOL aircraft into their trunk routes, serving Vancouver, Victoria, and Nanaimo. They also see opportunities to extend that service to Seattle, and this will be one of the topics covered in the Cascadia session tomorrow. Next. Another opportunity for short-haul aviation is seaplane service. Seaplanes need very little infrastructure, and most of the cities are located next to liquid runways. Seaplanes are a widely accepted mode of travel and for travel and flight seeing in Alaska, British Columbia, and Washington State, as well as in the Maldives Islands, where there's a large fleet of Twin Otters, over 60 aircraft, as well as the Caribbean. Most new seaplane services around the world try to clone Harbour Air in Vancouver or Kenmore Air in Seattle, two of the largest seaplane operators in Cascadia. Next. When it comes to seaplanes as well, electrification is gaining traction. Harbour Air plans to replace its Pratt & Whitney R985 radial engines in its Beavers and its Pratt & Whitney Canada PT6 gas turbines with Magni-X electric engines. The first flight of their converted Beaver took place in December of last year. One advantage is that Harbour Air has one of the shortest route networks in the world, so electric motors make economic sense for their 15 to 30-minute over-water flights. Next, here is Harbour Air's current route network, which includes the southwest coast of British Columbia mainland, as well as points on Vancouver Island, and they also fly harbor to harbor, Vancouver to Seattle, transporting tech workers. Next. Another market segment is short takeoff and landing aircraft. Short takeoff and landing aircraft require a number of technology innovations: high lift wing, increased flap deflection, leading edge devices, upper surface blowing to create high lift coefficients. A STOL aircraft is capable of a 4.5 or greater glide slope, and many of these aircraft, at least the turbine ones, have had beta on the PT6 engines to allow them to, in a sense, use the propellers as air brakes. There have been a number of very successful STOL aircraft manufacturers, and NASA has undertaken extensive research into STOL aircraft using the QSARA and the augmenter wing jet aircraft. De Havilland, with the development of the Twin Otter, next, also promoted commercial air service into small general aviation airports that had short runways, and also working closely with the government of Norway, developed with Widerøe, one of the national carriers, a network of STOL ports along the Norwegian coast that were gradually upgraded to larger aircraft such as the Dash 7 and the Dash 8. Next. The Dash 7 was the, I guess, pinnacle of the STOL airliners, but the timing was wrong. It was a 4-engine, quiet, short takeoff and landing aircraft that can land on gravel runways, but it was launched just prior to US airline deregulation, and the market shifted. Airlines were interested in faster aircraft with fewer engines and better operating costs. Next. One outcome of the STOL investment, however, was London City Airport, which was opened on converted dock lines on the Thames River. It began using a steep approach with the Dash 7 and was gradually expanded to other aircraft. And it's a case where STOL aircraft and STOL infrastructure went lockstep together and created a new air hub. Next, if we look finally at commuter and regional aircraft in the conventional sense, this chart shows the delivery stream of aircraft between 20 seats and 149 seats. If you look over time from 1969 to 2009, you will see that the number of small aircraft deliveries declines as airline demand shifts to larger capacity aircraft. Today, there are almost no regional aircraft under 40 seats still in production, except the Twin Otter, the single-seat PC-12 by Pilatus, the Cessna Caravan, and new piston models like the Tecnam P2012 Traveler, which has been delivered to Cape Air. One of the most interesting things is that since 2000, so over the last 17 years, and the data is next for the slide, I want slide 30% decline. Let me start again here. This chart shows a decline in short-haul air traffic in the United States between 2000 and 2017. The amount of traffic has declined by 30% versus 20 years ago in the under 500-mile category. And the value of that traffic that has gone away is $34 billion of airline revenue between 2000 and 2017. The loss of traffic was 4% in the routes from 0 to 100 miles. There was a 51% decline in traffic on the routes between 101 and 200 miles, and a 39% drop in traffic on routes between 101 and 300 miles. The routes that were largely sustained were under 100 miles, were primarily inter-island flying in Hawaii, Alaska, and off Cape Cod. Next, the decline in U.S. short-haul traffic was the result of airline consolidation that led to a drop in short-haul services, a retirement of smaller regional aircraft as airlines upgraded from 19-seat aircraft to 30-seat aircraft to 40-seat aircraft to 50-seat aircraft, and particularly the introduction of the regional jets by Embraer, Canadair, Bombardier, and Dornier. Pricing was disproportionately high on the short-haul segments, and the increased security that occurred, particularly after 9/11, that made alternate surface transportation modes more competitive. So a number of city pairs have been lost, but this is a recapture opportunity for electric aircraft. That's all I have to say. Thank you.
Thank you very much. That was a great analysis and really helpful to set the context. So I'm going to ask Jim to bring back the panelists for this panel. So that would be Ken and Brian and Seren, as well as Willie Taka and Shin Go from the prior panel, the panel that we did not have a Q&A for, so that we can do a joint Q&A. I'll remind you that those of you in the audience that you should have a question box in your dashboard, and a number of you have been sending in questions, but please feel free to send more questions in for this panel. And let's see. I'll put myself up there as well. Let's see, so we still need Willie. Ken, are we going to be able to get you on video, or are you going to remain just on audio?
No, for some reason, my video crashed halfway through the first panel, and I haven't been able to relaunch the GoToWebinar, so I'm just here as a voice.
Your voice, okay. And Willie, are you still on? Okay, perhaps not. So, for the Q&A, Ken, feel free to jump in since I can't see you. So again, thank you. I know 3 of you have looked at the perspective of Commuter Regional, and then Shin and Willie more from a global geographic perspective. One of the questions that came in from the audience actually came in on the first panel, but I think it is equally applicable to this panel, is, let me find the question again here. Here we go. Make sure to read it correctly. Would it be possible to get a panel view on when we're likely to see the first 30 to 50 seat electrically powered commuter aircraft in service with regional carriers? And I'll open it up. Yeah, go ahead.
So 30 to 50 passenger is a pretty big step. This industry traditionally grows from the bottom up. However, the government of Norway has proclaimed that all flights under 90 minutes, they want to see those aircraft electric powered by 2040. And because the services they would be flown on are the government subsidized stall port routes on the coast, there's funding available to actually support the operations. So I suspect that that may drive the 30 to 40 seat market sooner than one might expect. Pratt & Whitney Canada is looking at a hybrid electric scenario, which is a gas turbine engine with supplemental electric for takeoff and climb. I think we'll hear more about that on a later panel, but that's probably going to be the driving force, the Norwegian requirement.
Great, thanks, Ken. Do any of the other panelists have a comment on that?
I think it has a lot to do with what we mean by electric, and Ken sort of just touched on this. If we mean pure battery electric, there's a lot of challenges there, and of course everything depends on payload and range as well, what the range requirement is. Hybrid might very well happen sooner in terms of technological capability. However, the returns really on hybrid may not be as substantial as they would be with all electric. You buy into a lot of complexity and depending on the degree of hybridization. So I think it's challenging. I don't have a crystal ball on this one.
Any other thoughts from the panel?
Yeah, some of our projections have also put it out to about 2045, similar with like a trajectory on hybridization initially.
Great. Another question. This was originally for the first panel and addresses VTOL, but I think we can talk about it more broadly. The question was, how do you think VTOL timing introduction has been impacted by COVID? And how do you see COVID impacting the mix of regional versus long distance air travel in the future? So I think I'll turn it into more of an open COVID impact question for this panel.
Perhaps I can input first, because as I illustrated in my presentation earlier, I think this COVID-19 situation definitely urged people to think more about this so-called non-touch delivery. As we can see in China, because SF Express company in China delivered 11 tons of medical supplies in 32 days. If I remember correctly, I believe this might be the largest scale drone delivery as of today in the whole world, 11 tons by 32 days. And I've heard a lot of people in the industry from all sections, from all sectors, discussing this kind of non-touch cargo delivery. So I believe this cargo delivery during this pandemic definitely push forward the possible introduction of eVTOL, both unmanned and manned application.
This is Ken. I would just say that there's really two parts to that question. One is the impact of COVID on air travel, and the second is on the timelines for eVTOL. I think that what we're going to see in terms of air travel in general is that all the airlines have been hit very hard, and any routes that are marginal or any routes that have been served with uneconomical aircraft are going to disappear. So that as we look around our cities, if we imagine our cities as hubs sitting in the middle of a donut, that donut hole, which was traditionally the short haul routes, is going to get bigger. I think we're going to lose a lot of short haul flying now as airlines concentrate on the larger markets, and it could create a scenario where the eVTOL mission actually gets pushed out further, because there are no travel options if you're 50, 100, 200 miles away from a city, except by surface.
Yes,
Willie.
I think there is 2 points which could be done in this case. One is, in the beginning, when COVID struck and when the airlines had the problem, people thought that electric aviation and also eVTOL especially could be harmed severely. But as we saw, there have been coming up some larger strategic investments, especially in this time. For example, several millions for Lilium, which was additionally announced during the period. And there have been several other investors coming in. And another factor is, interesting-wise, that also the companies like Rolls-Royce, which on one hand, they announced that they will fire or release quite a number of several thousand people. They announced that in the electric aircraft development, nobody will delay, they even are hiring still. So I think it may accelerate the process in modifying aviation, even the crisis. At this point, we cannot see a negative which would say, okay, because of COVID, several eVTOL projects run out of money. It's not something which I have heard up to now.
One point that I would offer as well, Yolanka, on this one, I think it's kind of amazing what happened at the beginning of our period of COVID shutdowns. Companies realized over a period of about a week that telework could happen at large scales across their organizations, and they invested in the infrastructure to make that possible. People were working from home most of the time. And if we think about what that means going forward in the longer term, suddenly maybe people don't commute to work every day and take a car. Maybe they choose where they will live in a different way. Maybe they're more willing to move away from bigger cities. And suddenly the prospect of coming to the office once or twice a week, taking an eVTOL might be pretty promising, and teleworking the rest of the time. So I think there's some potentially very interesting things that are happening societally based on COVID, that depending on how long this lasts, we might see real changes in behavior. And I remember we did focus groups at Georgia Tech talking about, with regular people about would they take a transportation mode like eVTOL. And we interviewed a salesman who regularly traveled to the Atlanta airport from rural Georgia. And he made the comment, we asked him, would this be valuable to you? And he said, yes, it would. And we said, well, why? Would it save time for you and you'd spend more time with your family or more productive time at work? And he said, oh no, I would move farther away and buy a horse farm, and I'd travel in the same amount of time. Right, so I think this is, and again, I think back to Greg Bowles' presentation this morning about the Marchetti constant. So I think there's some very interesting things there that may happen when we think about the ability to telework, and that technology has really been proven now on a large societal scale.
Brian, I couldn't agree with you more. And as some of you know, I'm co-executive director of CAMI, the Community Air Mobility Initiative, and that's certainly what we're seeing as well, that the pandemic has created a shift in how people think for those people who are able to work remotely, and we all recognize that there are a lot of jobs for which that doesn't work, but recognizing that air mobility can be another mode in a multimodal metropolitan transportation system, and creates a different level of flexibility. Thank you. Let's see, we've got more questions now. And let me add that for the questions that we don't get to, I'm going to do one more question before we break. For the questions that we don't get to, we will pass those on to the panelists and have them reply and post answers after the conference. Okay, the question is, how do you see the evolvement of the landing takeoff ecosystem for electric vehicles in urban and suburban areas? In other words, an array of landing pads throughout the country's populated areas, so that these vehicles are conveniently available. Any comments on that?
I think that's going to be really directed by the technology and the industry itself. And then we're going to be able to see where this technology is able to plug into the environment for utilization. And also, of course, the demand from the public, but generally, I think it will come from the industry and what is available first.
Any other thoughts?
This is Ken. I think one of the risks is that a commercial aircraft operator, be it a helicopter operator or an airline, doesn't usually like to invest in infrastructure. I mean, they go into a route and they hope it works, but there's no guarantee. And so the cost of funding of infrastructure is not going to come directly from, the traditional commercial carriers. It's going to have to either be existing facilities or incrementally low-cost facilities to prove the concept and prove the market before the big investment comes from an operator perspective. However, there could be this pull scenario where real estate investors, et cetera, want the service and therefore make the infrastructure investment.
I think I would add to that certainly I think that there are two pieces to this. On the commuter regional side, as Greg talked about also, and I think Ken, you did, we already have, at least in the U.S., a strong infrastructure complex that is being underused, and that's GA regional airports. So for the thin haul market, part of this is looking at that resource and how we can use that for that market. I think once you start looking at more urban settings, and we'll hear about this afternoon, a big piece of that is that you're really involving that community at that point and that jurisdiction and those decision makers, because you're connecting into a larger metropolitan transportation system. And I know we will hear about that in the afternoon sessions. We are at the break. So it is now 1 o'clock on the East Coast. We have a half-hour break. During that time, we will have something playing so that if you come back in, you will know that you are properly logged in. A couple of announcements. So again, a half-hour break. We'll be back at 1:30 East Coast time. On your dashboard, there is a section with handouts, and please be sure to check those out. There are 2 of them from Vertical Flight Society. There is also a handout from Electra.aero, our platinum sponsor, and I want to make sure everybody gets a chance to see that. Again, I appreciate the flood of questions that has come in over the last 20 minutes. We will try to get to those with the speakers offline, and we will post those on our websites. Finally, if you do have to leave us, please remember that you can still register for Wednesday and Thursday. You can go to electricaircraftsymposium.org and follow the links to registration if you want to continue on either of the next 2 days. So see you back here in about 25 minutes. All right, thank you.
Thank you.
Thank you.
Thank you.